Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The environment inside the combustion chambers of gasoline engines and diesel engines differs significantly. In gasoline engines, a spark plug ignites the mixture of air and fuel to initiate combustion. In other words, a mixture with a relatively uniform concentration is combusted. In diesel engines, fuel is injected into highly compressed heated air to initiate combustion. In other words, a rich mixture combusts near the injector, while a lean mixture combusts farther away from it. Therefore, as with gasoline engines, toxic substances such as hydrocarbons, carbon monoxide, and nitrogen compounds are generated. However, the purification methods differ. In gasoline engines, depending on the engine specifications and the regulations of the market, NOx storage reduction catalysts or gasoline particulate filters may be used. However, three-way catalysts are generally the only ones used. For information on emission control devices in gasoline engines, please watch the video, Emission Control Systems, How They Work. The link is provided in the description. Three-way catalysts work most efficiently when the air-fuel mixture is around the stoichiometric air-fuel ratio. However, since diesel engines operate with a lean air-fuel ratio, three-way catalysts cannot reduce nitrogen compounds. Therefore, diesel engines are equipped with a diesel oxidation catalyst to purify hydrocarbons and carbon monoxide, an SCR catalyst, and an ammonia slip catalyst to purify nitrogen compounds. Additionally, diesel engines emit significantly more particulate matter than gasoline engines. The particulate matter is fine particle formed by the solidification of unburned hydrocarbons. As mentioned earlier, diesel engines have regions with both rich and lean fuel mixtures. Depending on the operating conditions, a significant amount of hydrocarbons remains unburned in the rich fuel regions. This particulate matter, known as diesel particulate, is the cause of black smoke. To remove this, a DPF, diesel particulate filter, is also equipped. First, let's take a look at the action of the diesel oxidation catalyst. Diesel fuel is injected into the combustion chamber, where oxygen has been drawn in. The main component of diesel fuel is hydrocarbons. Oxygen reacts with hydrocarbons, producing carbon monoxide, while unreacted hydrocarbons remain in the exhaust gas. Hydrocarbons and carbon monoxide are oxidized by the catalyst with the addition of oxygen, converting into water and carbon dioxide. Harmless water and carbon dioxide are released into the atmosphere. The SCR catalyst purifies nitrogen compounds in the exhaust gas by injecting urea and water into the exhaust stream. The mixture of urea and water is commonly sold as adblue. The nitrogen and oxygen drawn into the engine react at high temperatures, converting into nitrogen monoxide and nitrogen dioxide. When AdBlue is injected into the catalyst unit, it is converted into ammonia and carbon dioxide. Harmless carbon dioxide is released into the atmosphere. In the SCR catalyst, ammonia, nitrogen compounds, and oxygen react, converting into nitrogen and water. Harmless nitrogen and water are released into the atmosphere. The ammonia, that did not react in the SCR catalyst, moves to the ammonia slip catalyst, where it reacts with oxygen to convert into nitrogen and water. Harmless nitrogen and water are released into the atmosphere. In gasoline engines, the catalyst is controlled by the amount of gasoline injected into the engine, whereas an SCR catalyst requires a system to inject AdBlue. Additionally, since AdBlue freezes at -11 degrees Celsius, it is necessary to circulate engine coolant through the system to prevent freezing. To control these systems, An AdBlue control unit that works in conjunction with the engine control unit is also required, resulting in significantly higher costs. The diesel particulate filter captures particulate matter formed from unburned hydrocarbons that have solidified. In gasoline engines, the captured particulate matter is burned off by the high-temperature exhaust gases during rapid acceleration or high-speed driving. However, this is not possible in diesel engines due to their lower combustion temperatures. In diesel engines, the exhaust gas pressure upstream and downstream of the particulate filter is constantly monitored. When a clogged filter is detected, fuel is injected during the engine's exhaust stroke, sending hydrocarbons to the diesel oxidation catalyst. In the diesel oxidation catalyst, hydrocarbons react with oxygen and are converted into water and carbon dioxide, generating high temperatures in the process. This heat increases the exhaust gas temperature and burns off the accumulated particulate matter. In modern diesel engines, up to 5 fuel injections per cycle are performed for purposes such as improving fuel efficiency, reducing combustion noise, and decreasing the generation of harmful substances. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.